4.3, number 15. Gotta find where it's increasing, decreasing, concave up, concave down, any extrema, which is mins and maxes, and if there's any inflection points. So that's a lot to ask. 4.3, we're doing everything without a calculator, so all of our analysis is going to be based off of first derivative test, second derivative tests, and so on. So we'll start with our first derivative, y prime equals okay. So we have derivative. Let's find our potential mins and maxes. So it's 2 over 5x to the 4/5. If we set that equal to 0, we're not going to have any solution, because the only way a fraction is 0 is if the top is 0, and 2 doesn't equal 0, so that's no solution. But there is potential for an extrema at x equals 0, because that makes the bottom of our derivative 0, which is undefined. So at x equals 0, something happens there. So let's do another derivative, y double prime. I'll use this top version. So it'd be negative 8/25 x to the negative 9/5. So that is negative 8 over 25 x to the 9/5. So same thing here. We set the second derivative equal to 0. We'll get no solution because it's just a fraction, where it's just negative 8 on top. But we could have an inflection point at x equals 0. So something's going on at 0. We have an undefined derivative, and if the first derivative is undefined, second derivative is going to be undefined at 0. Alright, so now we could put 0 into our second derivative to check concavity, but it's not defined there. So if we plug 0 into our original equation, let's get an ordered pair there. So 2 times 0 is 0 plus 3. So 0, 3, something happens. Let's pick points on both sides of x equals 0, and we can check its concavity. So let's plug 1 or negative 1. So y double prime of negative 1 and y double prime of 1 to check concavity on either side of 0. So if I plug negative 1 into our second derivative, I get negative 8 over negative 25, which is a positive 8/25. So it opens up. Alright, so now let's find the second derivative at 1. We get negative 8 over 25. So it's going to be concave down. So it does change concavity at 0. So it looks like there's an inflection point at 0, 3. Let's pick points on either side. Let's find, so we know it's concave up and then it goes concave down, but we don't know if it's increasing or decreasing. So we could plug in negative 1 and 1 into our first derivative, or we can just plug it into our original. And if we plug it into our original, we can determine which one is a higher y value. So it doesn't matter. I'll just plug in y prime of negative 1, plug it into our first derivative. If I plug negative 1 in, that's going to make it positive 2/5. So that means it's increasing at negative 1. And then y prime of 1, if I plug it in, I get positive 2/5. So it is also increasing at -1. We don't have any mins or maxes, so it looks like it's going to increase everywhere. So from -infinity to infinity, and decreases never. It's concave up until it gets to our inflection point at 0, so -infinity to 0. Concave down from 0 to infinity. And we have none or never extrema for this problem. So it could be more of an interesting problem. Not a whole lot's going on. I have a graph here just to confirm. You can see that it does increase the whole time. It appears that it's concave up and then concave down, so there's an inflection point at 0,3. Everything we found analytically supports the graph of what we have here.